The next topic that we are going to discuss is whether we can estimate the random effect coefficients. Now, this sounds like an oxymoron. If it is not even a parameter, it is something which is random, how can we estimate it? So we should better correct it by saying that we want to predict these coefficients. Now, still the question remains that we say we are using random effects because we are not interested in the specific values of these particular coefficients. These are something like a random sample that we generated from a large population of similar such coefficients. We had many villages. Out of that we chose some random 3 villages. So we are not interested in these 3 villages. So why should we ever care about predicting about these 3 villages? Anyone who is going to read the report in future will not care about these 3 specific villages. True. However, in animal husbandry, that is, people who care about how to improve, say, the milk production of cows, they like to have predictions of these things. So basically, the reason why they like this is this: you have got, say, different male cows and female cows, oxes and cows, and you mate them. You want to know whether the resulting calves are good with respect to some measure of health, and you want to link that up with the various properties of the ox that you use. Now, these oxes are chosen randomly, so random effect. However, the same oxes are going to be used for mating even in near future. So it is important to know if one particular ox produces better calves than another. So that is why people in animal husbandry care to predict these random effects. Now, how do you do that? In case of fixed effects, we had got BLUs, best linear unbiased estimators. So naturally, here we have a similar concept which is called a BLUP, best linear unbiased predictor. So here is the definition. Suppose B is some random coefficient that we are trying to predict. Then L prime y, a linear function of y, L is a fixed thing, will be called a BLUP, a best linear unbiased predictor for B, if the natural definition, variance of L prime y should be minimum, subject to the condition that this is an unbiased predictor of that. Now, had this been a parameter, unbiased would mean its expectation always equals that, but this being a random quantity, we have to put that also inside the expectation, and we'll say expectation of L prime y minus B is always equal to 0. Notice the identity that I am using. By this I mean whatever parameter values you choose, it will always be equal to 0. That plays the role of unbiased, and subject to that, we want to minimize the variance. We call that a BLUP. The question is how to find them.